whoever did this, you are a genius madman. So I appreciate you doing this up.
Today, I'm going to tell you about my favorite theorem,
Now,
the ham sandwich
as
theorem.
you know,
This is a
I often
ham
talk about this ham sandwich
Okay,
thesis in
kind of
topology.
sad ham sandwich, but it's all I've got right now. The ham sandwich has 3 components: 2 pieces of bread and a piece of ham.
That's not the one I usually do with it. I didn't know there was actually a ham sandwich thesis out there, but by all means, whoever got the credit out there as the scientist, you're more welcome to it. Gonna have to use some of my other stuff. My Chaos Space Marine unit there, while talking about Wolfgang Kettler, 2020, I don't know, a few years ago, Nobel Prize on Bose-Einstein condensates and dropping it out of solution. So, while he's doing this, you listen. I'm going to rip out a piece of paper here. We're going to remake the universe, because I did this video before, but it didn't quite work.
Is that this is true for any shapes with any orientation in 3-dimensional space. Now, before I prove the ham sandwich theorem, I'm actually going to begin by proving the pancake theorem, because a pancake is thin enough that we're going to approximate it at just a 2-dimensional object. If I move my knife in parallel, at one point there is less than half on the left side, and at another there is more than half on the left side. So there must exist one of those parallel cuts where it is exactly equal. I might have to eyeball a bit to approximate exactly where the cut should be, but I
roughly
know
a circle,
that it must
roughly a ham sandwich, whatever it may be. Okay,
Okay,
so how do we get this square? How do we make this in some way roughly the inches that it needs to be inside here?
And at B, there's a height f of b. Then for any intermediate value, any value between f of a and f of b, it's an existence theorem. It says there exists some point C
that 1 is always 1/2, and that 1/2 is always 1 whole. That I really can't do either with those things. And so what we need to do is 1/2 is really a quarter, and so on and so forth. But we're going to need to make this thirds. We're going to need to make this 99.9%, because a fractal is 1/31st of a 32nd, 31 32seconds. And so we have to be able to get this to a rangeable size that says that it's appropriate. So now that we folded those two, we can fold the 4 things and make this square.
That one exactly in half. That's great for the red one, but it's quite unlikely that that exact line is going to cut the blue one exactly in half as well, and indeed in this case it does not. However, if I start rotating that angle around, making sure to always slide my line so it's cutting the red one exactly in half, I can basically repeat that intermediate value argument again for the blue pancake. If I choose a specific side of my line, say underneath, then I can always talk about the proportion of the blue pancake that's underneath the line. Sometimes that's less than half, sometimes that is more than half of the pancake, and thus there must be some angle where it cuts the blue one exactly in half as well. So the pancake theorem says that for any 2 objects, there's always one line that you can cut exactly in half.
So we took that round circle, or that rough explosion of the universe, and we made it fairly square. This is important. Now, no matter how we go about folding this, this will only turn into quarters. It'll fold into half, and you'll get 4 parts. You'll get photon, gluon, W boson, Z boson out of this.
So I want to tell you about another really fun theorem in topology called the Borshak-Ulam.
And so at that we have 1, 2, 3, 4 axes at this, and we need to make this thirds so we can get to some other triangulations of the sun, the moon, phase, whatever sinusoidal wave function we're working here. He's wearing it pretty good. I'll give it to you. He did pretty good work here. But in order to do that, we actually need to have, you can't necessarily just turn it into thirds. You have to have a square area to determine 1. Even if the outside edge is a little bit more, or a little bit that you had a cutout inside of there, if you take the rough area out of that, it would still be 1 whole circle with a radiant of 0.5 or a diameter of 1. So we need to fold this so that we get more
must be some location where
without,
the temperature
we didn't
at
use
the
any
red point
measurements. We're
and the
just using
temperature at the
geometry. A
antipode
P,
of the
P
blue
and a Q
point
point
is exactly
to
the
do this.
same.
A
This is actually
bibbit,
just
right?
intermediate
2
value here.
bibbits in a
Once again,
competition
if you're saying
for
the
survival.
temperature
This
of the
one
point is initially
did thesis
less
A,
than
this
the
one did
temperature
thesis
at its
B,
antipode.
but they're
As
in an
you go all the way
environment
around the
where
circle, it's now flipped and is more than
it's
the
different.
other side.
And if you try
Once was
those
less,
same
once was more,
bibbits
somewhere in the middle, it has to
with
be
different
exact.
survival function
What's really important is I can do
in
this
round
up
robins like
dimension.
that, you'll get different
Now I'm
results.
considering 2 points at
But
its
they shouldn't.
antipodes
They
where
they
they're
should
allowed to
within
be
their field
anywhere on the
act
surface
that way.
here,
If there was still
not
things
just
close
completely.
within the
And so
bibbit
now what I'm
design,
gonna do is I'm
they
gonna
are
figure out
highly
any point
probable
on the
to
surface
have
of
that
the
same
Earth, which I
success
will now
rating.
call S2, two-dimensional, is I'm going to tell its temperature and its pressure. I'm going to give a two-dimensional output. That is, we can kind of imagine plotting from these points up into a plot.
So now we got that
and pressure
4x4, which we can
two-dimensional output.
integrate
Then
into
Coulomb theorem
this
says that there
this
exists
XYZ.
some
We
spot
know
where
that there
spot and
is,
its
which
antipode
this, if I
has
did
the
this
exact same
correctly,
temperature and pressure. So the claim here is an existence
this
theorem
third,
that says somewhere along that equator there is a point that has the exact same temperature as its antipode. Now, I'm not going to prove this theorem
measured
in this
correctly.
video, but I have a previous video that proves
Yes.
a related
This third
theorem to
is
work
exactly
through
1 inch.
using a delightful combinatorial proof. So
we need to fold it down on
now
2
let's turn to
axes
the
here.
scenario of 3 objects in 3 dimensions.
Now, why did I do that?
And we want to cut
I knew that there was some
exactly
things. I
in half.
needed a roughly a 2-inch
There's
circle.
a nifty trick for
I
dealing with
needed
directions in 3 dimensions that I want to show
so
you.
that this way
Let
that
me
this
consider
1 by
a
1
sphere
with
centered at the origin. This is not one of
segments
our 3 objects. It's just going to be a
at
reference
thirds
sphere.
and
If I put a
quarters,
point on
because
the
I can
surface of
fold
the
this in
sphere,
half
this
again
generates
and get there. I will
the
get a
direction by
1 by
inserting a
1
line
with 2
through the origin
surfaces.
and
I
through
will
the
get
point on the
a
surface of the
4 by
sphere.
4
Thus, any point on the
because
surface of the sphere is associated with a line like this.
if they're bifurcated, you'll have
The reason I care
2
about
1
direction
half.
is that
If it's in
direction
quarters,
in
you'll
3
have
dimensions
quarters.
defines an orthogonal
If we're
plane.
playing
Actually,
X, it can only be half.
defines
It can
a
only be
family
half.
of orthogonal planes all up and down that line.
And
Okay, back to the ham sandwich.
essentially,
I have 3
there are
objects.
2
I want
points
to
in the
slice
middle here.
all of them in half
We
as
know that
well,
the
and I'm
the
gonna
X
put
that
up
we
my
originally made, the
reference
folds,
sphere at origin.
leads to a point in the
I'm
bottom
gonna color
rough.
one of the
If I
3
didn't change my
yellow, we can
orientations
focus
around
on
at all,
that one first.
or didn't,
For
if I
any
would
point
label
on the
them as I
surface of
told
my
you, I'd know
reference
that
sphere.
in
I can
the
use the same
what would be,
intermediate
we'll
value
use this
theorem
as
argument
0,
that we
0.
use for pancakes to say that I can
The
move up and down that family of
2
orthogonal planes
1
until the
position
first of the
and
3
the
objects is split exactly in half.
the 1 2
And then this can
position,
be done
or if
for
you want to say
every
A B
direction on the
1
reference
2,
sphere. As the point
would
moves
be
around the reference sphere, I
that
can
the point
always
at
move up and down that family of planes
B
until I find at
2
least one that's going to cut
and
the first object in half.
A2
It's unlikely to cut the other objects in half, but it will always
are
cut the
in
first
sense the range.
Now let's look
There
at
was
the
somebody
other
talking
2
about
spheres. If I pick a side of the plane, for
oh,
example,
I
to
can't
pick a
remember it.
direction
I
from
think
the
it's the
origin out to the
intrinsic
point as
state,
the
the
positive direction,
intrinsic
then
nature of that
consider
thing,
the
that there's
portion
going to
of the
be a
volume of
range,
the
63 or
object
73
that is
parsecs
on
in
the
here that
positive
says,
side of the
I know
plane.
3B1B
For
did
instance,
this with
here the
logarithms,
plane cuts the first
and the
object A1 in
Putnam
half by construction.
that talks about that
Looks
environment
like
of
a
these 2
little
states, or
bit
those
A2 is
3
also on the
bibbits,
positive side,
that
but
we're
none
going to
of
say,
A3.
does it cross through
I
the
want to use
middle
this notion
section of this while
volume
trying
on
to
the
hit the
positive
plane
side of
on
the plane
this?
to
Are they
construct
lined up
an
in such a
explicit
way, or are they offset?
Okay,
If
so
it's
let's
not so much
summarize
that they
where
have
we're
to be
at.
perfect,
We
but do you
began with
understand
the
that?
point on the surface
If
of the
they're
sphere.
not, and
The
you have
point
to make a
then
junction
generated
point
this line
that
out
deals
from
with
the
that, that's the
origin through
ham
the sphere. It was like
sandwich
telling me
topology
a
to the
direction.
job. It's what
Given those
derivative
directions,
U,
you've got
money,
a family
AU,
of parallel
is
planes,
going
and
to be worth in
specifically
terms
there was
of
at least
how many
one of
gold
that
pieces
family
you
of
would do,
planes
or
that was
silver
cutting the
pieces,
first of the
AG,
objects in half.
the atomic
Now
weight
what I'm gonna do is construct a
1.7,
function. Its
or
input
excuse me,
is P, that is, its input is a
107.868 for
point
silver,
on the surface of the sphere.
is the weight that I need it to
Something
be
two-dimensional.
in the
That is,
folds and the
plot from S2 to
homogenization
R
of this
sphere
idea to
is
make
a
sure all those
two-dimensional
points
surface.
are
Because
connected
it
on this
distributes the
plane.
volume of the second
And it's a
object
great
that's
thing to
on the
do
positive side of the
for
plane
a lot
to the
of good
volume of the
reasons
third
as
object that's on the positive
Chaos
side
Space
of the plane.
Marine.
These are just numbers, some volume. So what I have is
I
a
usually,
map from a sphere to
when you've been playing with me, you should
two-dimensional
know
real
that
space
you
output.
see this, you know we're playing function of the
It's a
Dominion.
continuous
The
function.
force is a
You follow
value.
the P
Here
around
they're
a
saying the
little bit,
force is
plane
a
doesn't
point.
change very much, it's continuous.
On this map, that grid
And so
point
Borsig
has
applies.
that function of the Dominion into it. I need whatever in the universe you're doing that you're about to graph to do this. Piece bread, ham, bread. Maxwell's equation is going to work that same way. Here we're saying that the sandwich points are that peanut butter and jelly, but here, ham sandwich design. First you got to get ham, first you got to make bread. And you'll see how this topology changes. If I had a bread factory, if I had wheat, if I had, you take that all the way back to the land that you need to do that, then on the plane you could say that these things are aligned in such a way. You may not need them to be in that orientation. They might have a order where it's like, I didn't need the wheat factory, I needed the bread factory by virtue of how I'm conducting this topology or this inequality or the system. Now you might still have system errors in the fact that you can't advance your cells of bread or ham in this if you're not in that farm department, because there will be limitations to those values where the points will not line up if your supply and demand doesn't quite correlate R, P, Q over derivative there in the coffee cup of new.
Imagine you're living in n dimensions.
Alright, so I thought that was cool. A+ on that ham sandwich theory. I love it.
You can find some